In our lab last week, we modeled a vibrating beam as a single degree of freedom system. This week we'll be using the same sort of concept and further explore the modeling of single degree of freedom systems. However, this time we'll be doing the modeling using MATLAB. You will download a MATLAB script file called freeunderdamped.m. Working with the contents of that script will basically be the first half of the lab. Besides just reading through the lab activity and backgrounds this time, I also highly recommend that you take just a few minutes to look over the script file and how it relates to the questions being asked, as it can save you a lot of time later. And as you can see here, it's really not that long of a program, so it shouldn't take too long to look over. For now though, let's take a look at some of the new MATLAB commands that you will run across in this lab. When you first open the program, the first command you see may actually be new to you, and that's the input command. Basically, it's just another way to assign a value to a variable. When used, it will prompt the user for an input in the command window, and the command goes something like this. So let's just pick a variable, let's call it A. We're going to say that's equal to input, and then parentheses, apostrophe, apostrophe, close parentheses. And then anything that goes between the apostrophes is a message that's shown to the user. So we'll just say example. Now when we save our program, let's hit run. Now notice we're immediately taken to the command window, and MATLAB shows us the name of the program that was run, so untitled, and then here's our prompt. So then we'll just give it any kind of value. Let's just call this one 5 and press enter. So you can see that MATLAB spit out our answer here in the command window, and then like normal, as we assigned it to a variable, it saved it over here in the workspace. So this command can be useful at times, but for our purposes in this lab it's best to delete the input command wherever you find it in the freeunderdamped.m, and just go ahead and assign the values that you need to the variables so that you're not constantly taken to the command window to input the values that you need. And this should help you complete the lab faster. The next command you will encounter isginput. This allows you to pick points off of a plot which you can assign to a variable. Now this can be very useful because it allows you to have the x and y values available to use in your program. But before we do that, we need to make a quick and simple example script file to produce a plot. And it just so happens that I have one right here. Alright, and you can see this is a pretty simple little program. Clear all, CLC, and a value of x from 1 to 50 in 0.1 increments. And then we just say y is equal to sine x over x. Alright, so, and then of course we plot it. So let's run the program, and we should get a sinusoidal graph like this. Alright, so now that we have our plot, let's go to the MATLAB command window. Alright, so to use this ginput command, we first need to start with a variable. So we'll just call ours xp and yp in brackets. And that's going to be equal to ginput. So also what we can do here is we can follow this command with a pair of parentheses and a number. And that number specifies the amount of points that we can pick off of our graph. So let's just go ahead and say 3. When I hit enter, you'll see that the figure just pops up for me just automatically. I didn't even have to click on it to bring it up. And also notice that my mouse is now a crosshair. Now what this means though is that MATLAB is not tracing the line. So if I clicked way up here, I would get a value of about 0.8, while our real value is down here in the negatives. So what this means is you have to be very accurate with how you're clicking on these points here. So I'm just going to pick 3 peaks, just for no particular reason, but let's click that one, and this one here. Alright, now you can see I have XP with my 3 values and YP with my 3 values. And of course, as always, they're saved here in our workspace. The second portion of this lab utilizes the Simulink package in MATLAB. You should have already gained a basic functional understanding of Simulink during Lab 1. This time though, we are using it to make a model of a single degree of freedom system, so there will be a few differences. Without going into too much detail, here are a few things to take notice of. First, don't be confused by the integrator block not having an integration symbol. Instead, it is symbolized by 1 over s, which you should recall is integration in the Laplace transform. And you can see the integrator block right here and here. And the background does go over the Laplace transform properties a little bit before you get to the model. Now second, if you look at the Simulink model on page 3 of the lab background, which is what we're looking at right now, you will notice the Simulink model of the single degree of freedom system here. This model can be a bit confusing at first, but if you pay attention as you read the lab background, you'll see this is just a way of solving the differential equation of motion for the highest derivative, which is acceleration. And that equation is given right here. So this is what we're solving for. And you can see that once again right down here. So all this model is doing is solving for acceleration in the equation of motion, which is what all of this means right here. Like I said, just go over this in the background, and then you can see that we get displacement as our output.